I think Sushi is muted.
Go again.
Can everybody hear me?
Now I can.
Okay, perfect. Welcome everybody to today's iTOOsday. Joining me on this presentation is our PI product head, Fiso, and Nadia Shiba, the specialist claims manager. Our two esteemed guests are Warren Hippner and Martin Bass, whose names are synonymous with the insurance industry / construction industry. Warren Hippner is an attorney. He's a former partner at Weber Wenzel Insurance Department and then Clyde & Co. About 2 years ago, he started his own firm, Hippner & Associates, and his focus has been on insurance litigation. Martin Best is our specialist loss adjuster, and his experience and qualifications extends to civil and structural engineering and claims investigation. Our topic for today is focused on the economic challenges and climate changes within the construction space. And whilst Warren will focus on an essay perspective, we'll get Martin Glass to talk about case studies and ties case studies to these two aspects. Warren, I'm leaving it in your hands.
Thank you very much, Shushi, and welcome everyone to this session of iTOOsday. As Shushi had said, we are going to have a look at some of the issues relating to the construction industry. Both myself and Martin are going to deal with the issues. I'm going to start by looking at the industry in South Africa, the construction industry in South Africa. The aim there is to try to put it kind of into the big blue sea of South Africa's economy. I'll then turn to look at some of the challenges facing the industry. And then I'll hand over to my colleague Martin, who's going to deal with some of the claims and the real life issues that arise in the area of the construction industry. We will have a question session at the end, but during the course of the presentation, I understand that there is a chat line that is available and that Nadia and Sushi will be monitoring that chat line. And to the extent that there are any issues that need to be addressed, they will address them. And if necessary, we'll raise it with either myself or Martin at the end if we need to address anything. So please feel free to utilize that. Right, so we've got quite a lot to cover, so let's perhaps just kick off. The first part of what I want to talk about, let's just get this done. Okay. So let's talk quickly about the construction industry and the economics of it. And what I want to do here is I want to put it into the South African economy so we can just understand its role and who the players are. So in the ordinary course, South Africa's construction industry contributes about 3 to 4% of GDP. The South African GDP in 2024 was about 7.5 trillion rand. That comes out to quite a substantial amount if you think about it, the 3 to 4%. Important is that it's kind of a stable figure. So year on year, it's always in the 3 to 4% of GDP range, which has two issues that arise from it. The first one is that it shows you that the economy determines how the construction industry does. So the better the economy does, the better the industry does. But it also shows you that the industry is sometimes a leading light or an indicator of where the economy is and whether the economy is doing well or not. The GDP itself has grown about 0.6% from 2023 to 2024. It's anticipated to grow between 1 and 1.5% from 2024 to 2025 and about 1.8% to 2026. So it's supposed to be an upward trajectory, hopefully. And a lot has to do with, of course, what's going on in America and tariffs and those sorts of things, but hopefully it's able to fulfill its promise. The public sector accounts for about 70% of the expenditure and the work done in the construction industry. Private sector is about 30%. As I said, it's about 270 million rand in, 270 billion rand in total. Of course, the large-scale industrial projects are the domain of the government and state-owned entities. They have the financial backing of the state, and those, for the most part, attend on South Africa's needs in relation to energy, housing, infrastructure, and the like. The private sector is more focused on the commercial and residential. There is a trend developing, particularly in renewable energy, where there is partnerships between the public and the private, so-called PPPs, public-private partnerships. And the intention there is kind of to bring the best of both worlds together with the financial backing and the infrastructural needs of the state, combining then with what has proven to be the ordinary better efficiency of the private sector, so that together they can put something together that makes sense and is worthwhile. Let's look at some of the details of it. So South Africa has about, I think our population is about 65 million, and of those about 15 million are formally employed. About 8% of those formally employed are employed in the construction industry. So you can see it, the industry punches above its weight as far as its contributions to GDP is concerned. It's only 4% contribution to GDP, but it does have an 8% employment factor. That works out to about 1.2 to 1.3 million South Africans employed in the construction industry. The division of those demographically, about 70% are in the semi-skilled or unskilled. And of course, South Africa's majority of its employment workforce is in that demographic. So it is a major contributor to ensuring that those who are most looking for jobs are able to get jobs. As far as the professional side is concerned, about 15% of those employed are professionals. The majority of them are, of course, engineers, and the reason for that, obviously, is that there are multiple fields of engineering: civil, structural, mechanical, environmental, electrical, etc., etc. Okay, let's go on. Let's look at the role players in a little bit more detail. So as I said, there is the public, the government side, and then there is the private sector. As far as the government or public state side is concerned, there has been a decline from 2018 to 2020 as far as government involvement in the construction industry is concerned. But an increase turnaround has come about since about 2021, and it's envisaged that that increase is going to continue into the future. Certainly, if you have regard to the promises made and the undertakings given and the indications given at the SONA address, which was given in February this year, I think. There you would see President Ramaphosa spoke about 940 billion rand being set aside for infrastructure over the next 3 years. That's mostly in relation to roads, bridges, dams, ports, airports, and particularly power. Of that 940 billion, very promising. A little less promising is the reference to about 375 billion of that being allocated for expenditure by state-owned entities. And there we're talking about Eskom, Transnet, SAA Development Bank, SA Independent Development Trust. And of course, we've learned from experience in this country that the state-owned entities are not the most efficient entities to be tasked with spending public funds on infrastructure projects. And we'll talk a little bit about that when we talk about some of the challenges that face the industry. Let's look quickly at the private sector. On the private side, there have been substantial challenges. And when I say substantial challenges, I mean substantial challenges. The big players, and I've listed, or the former big players, I've listed them: Murray and Roberts, Avenge, Group 5, Basil Reed, Esau, Jurisic Brothers, the list goes on. Very few of them, I think only one of them, exists as they previously did. The private construction industry has gone through major difficulties and major shifts. Almost all of them have gone through some sort of liquidation, business rescue, had to refocus their business. They've just had to change to be able to survive. Some of them have had their shares suspended. Group 5, I think, was in business rescue. Basil Reed, business rescue. Esau was in business rescue. Murray and Roberts, it had sold its construction and Concord Arms to a consortium. I think it was about 2017, if I'm not mistaken. Went into business rescue, the Murray and Roberts entity. About 3 years ago, its share price was at about 14 Rand. It's now, I think, at about just over a Rand. And if those of you who follow the news would know that last week there is talk about it selling its last mining operation out of the business, and for it to be then finally wound up and closed down. And that's a company that's been going for a very long period of time. So kind of sad in a way, although progress is progress. Perhaps the other one I want to just mention is Avenge. They too, a few years ago, were at a share price of about 30 Rand. I think they then dropped to about 11 Rand, changed their focus, exposed themselves to overseas markets and overseas business, picked up and sustained some sort of recovery, I think, in about 2024, late 2024. Most recently has experienced some delays in one or more of the projects, and I think in Southeast Asia. And as a result of that, I think it lost about 25% of its share price. And I think it's now trading at about 6 Rand. But also facing challenges. But Avenge is one of those that seems to have weathered the challenges and seems to be coming through. At the moment, the players that I've identified there are in the second bullet point: Avenge, WBHO, Robex, of course, Murray and Roberts, and of course they may not be around much longer, and Stefanuti. The way they're listed there is in accordance with their income, their gross income. 37.5 billion was Avenge for 2024. WBH, I think, was about 28 billion. Robex 17. Murray and Roberts was 13, and Stefanuti was about 7, I think. And the bigger, surprisingly, the bigger employers out of those two is WBHO and Stefanuti. I think they have about 9,000 employees each of the total. Let's talk then. Okay, so now we know, there's who the players are, and you would see it's a substantial operation within the South African economy. And let's just look quickly at some of the challenges that they face and why they are where they are, and why they are not where they ought to be, I suppose, is the issue that we're looking at here. And of course, the first one is all of our bugbear load shedding. Introduced in 2008 and has never really gone away since then. There's been fluctuations up and down. There's been promises. There's been government ministers. There's been all kinds of things. Doesn't seem to go away. Those who followed the news this morning, you would have seen there is talk about them spending billions of rands. I think it's about R1 billion every 10 days on diesel expenditure to keep the lights on. And of course, that's not sustainable on a long-term basis. So, of course, the challenge that arises from load shedding is it affects the time to complete projects. There's delays, but not only in relation to the projects themselves, but also in relation to the projects that are in the pipeline, and there's a knock-on effect on those pipeline projects. The cost implication, of course, well, time is money, so any delay is somebody's got to pay for that. And of course, there are then efforts by the entities involved to try and protect themselves and take mitigational steps to avoid the consequences of the load shedding, which in itself is a cost implication for the project, and somebody has to bear that cost as well. And then, of course, there's the risks. And sometimes we lose sight of that from a health and safety perspective. I mean, it could be as simple as workers having to work in a low light environment or in a less ventilated environment than what they otherwise would have to if there was no load shedding. It could also be a knock-on effect from delays where there's now an effort to catch up. And so shortcuts are taken, and of course, the shortcuts comes risk, not only for the quality of the project, but very often for the health and safety of the workers. Load shedding, a major problem. Okay. Next one is skills shortage, and we're talking particularly about skilled labor, and this is an issue that has been a long time coming. And it's kind of, for the most part, been laid at the door of an inefficient skills transfer. And it's ironic in a way, because the construction industry was at a time very well known for having a very well arranged apprentice program, with a strong commitment from both the trade testing side, the collaborative involvement of the employers and the employees, and quite a clear plan of action insofar as training apprentices up through the ranks was concerned. In about 2000, that's about 1998, 2000, I think it was, the government decided to bring out SETAs, the state sector education training authorities, thinking that, as governments do, I suppose, particularly our government, that they could do this more efficiently, and try to intercede these SETAs into the relationship between the employers and the employees, trying to improve the efficiency of the skills transfer. Unfortunately, that has failed. There is no doubt that has failed, mostly as a result, it seems, of government inefficiency, and also because of things like corruption and the like. The added to that is this question of subcontracting out to labor brokers. A lot of the construction work was then being, because of the skills shortage, labor brokers then stepped in to fill the gap. The consequence of that then is everybody takes a short-term view. So you have the employer taking a short-term view of the labor broking employees. They're not there permanently. They're there just to do a job and move on. So there's no commitment. The employees come in there with a short-term view, so there's limited commitment from their side. So there's from both sides, there's no real commitment to a skills transfer and to a learning process, and it's just not conducive to a proper skills transfer arena. The overall consequence of all of this is that there is now somewhat of a decreased talent attraction into the construction industry at a skilled labor level. It used to traditionally be that people would often think of it as a good place to get good training and to get a good job which could sustain you. That doesn't seem to be the case. The consequence of that is now we have quite a lot of foreign nationals being employed to fill the gap. And Martin perhaps will talk about one of the issues that arises from that, but certainly in the George collapse, there was a substantial number of foreign nationals employed, and a number of those foreign nationals were unfortunately killed in that collapse. And I don't think all of them have been identified to date because of that issue. So it comes with its own challenges and difficulties filling that gap with foreign nationals. Of course, no presentation or challenges would be proper without a reference to corruption. South Africa is ranked, I think, 82nd on the Corruption Perceptions Index. I think they've got about 180 countries 160 countries that they monitor. We're 82nd, and surprisingly, since 2021, we're dropping. And when I say dropping, meaning we're worse off. We are looking more and more corrupt. Corruption is prevalent in South Africa at all stages of the process. One need just look at the 2010 FIFA World Cup bids and construction bids to as evidence of these things going on. And it ranges from tender rigging, fronting, kickbacks, undisclosed conflict of interest. Most recently, something like, I think, more than 10% of Eskom's staff was shown to have conflicts of interest that were undisclosed. Yesterday, I think there was news of, in relation to the Independent Development Trust, of some 33 million rand being paid to family members, and from the trust that was destined for better intents. So it's a pervasive problem, and it's something that the country really needs to get hold of. And one of the consequences, I suppose, is this next heading, which is our construction mafia. And sometimes you'll see they're referred to as business forums, and of course that's just a very blatant attempt to give some legitimacy to what is otherwise nothing more than a criminal enterprise. It started out in KwaZulu-Natal, and it started out kind of as a distortion of the transformation objectives of BEE, 30%. And criminal syndicates realized that what they would do is they would just come to a project and demand 30%. And initially, it was 30% of the work to be done by local laborers. But of course, there was a realization, well, you don't even need to do that. We'll just demand 30% of the job as a whole, and won't do any of the work. So it adds nothing. It is pervasive. It involves extortion, violence, intimidation, disruption, and it is spreading. It has spread to other provinces. Cape Town is the one at the moment who's jostling with it and trying to take control of it. It's so pervasive that in many respects, it's now thought to be part of the cost of doing business. I think that's related to the potential political connections to some of these business forums, as well as the role of organized crime. The Department of Public Works and Infrastructure is trying desperately to try and get hold of that at the moment. I think they reported last week about 240 arrests since November. But not without, there's now death threats being made at members and at the minister. And so it's difficult to root out. It's quite entrenched. Talk quickly about some of the social and political factors. Some of them I've already mentioned. Perhaps the first one is this question of political uncertainty and instability. First of all, investment flow into South Africa for the purposes of large-scale projects is very dependent on stability and certainty. We have at the moment the government of national unity, which in some ways brings some certainty, but in other ways brings uncertainty. There is quite a lot of political change, flipping and flopping, and none of that is conducive to the political certainty overall. Infrastructure and service delivery failure, well, that's kind of self-evident. Not only do the projects suffer, but you have the employers and the employees having no electricity, no water, no motivation, having to come to work under those kinds of environments. Excessive bureaucracy and no clear government policy action. And you would think that those two would be irreconcilable. You would think that with more bureaucracy, you would have more certainty. Well, for some reason, we just haven't seemed to be able to get that right. We seem to have a lot of bureaucracy, but still a lot of uncertainty. So it seems the bureaucracy is not focusing on the right things. And an example of that is ArcelorMittal. You would know recently it closed its long steel operations. And as I understand it, it's been complaining for a long time to the government about cheap steel imports from China, which were not of adequate quality and which were endangering its business. And the bureaucracy just was not able to or did not respond adequately. And the end result is we are where we are, where ArcelorMittal has had to close that arm of its business. Health and safety. I already mentioned, health and safety issues. It's construction industry is considered by the Department of Employment and Labour as a high hazard industry, and it's something that we need to keep focus on when trying to deal with or grapple with the challenges to the industry. Climate change. So there obviously is storms, flooding. April, I think in May 2022, KwaZulu-Natal is clear examples of the kinds of massive storms and flood damage that one can see. The sea level has risen, I think, 0.5 centimeter in 2024, and that's globally, and that's more than what they anticipate. Comes with its own consequences of threats to coastal properties and protection needed for coastal properties. Temperature changes, of course, a number of construction industry materials are temperature dependent. Similarly, drought and water needs, these have an effect on the projects as well. There's delays, damages result, and of course, then there's also costs of preventative measures that somebody's got to take and somebody's got to recover, or somebody's got to pay for. Carbon footprint, another challenge for us. I think the construction industry in South Africa is about 4% of the direct total emissions of South Africa. What it does is it creates difficulties with South Africa meeting future active treaties or convention requirements. That means that potentially construction methods are going to have to change, which itself is costly. Another consequence of that is the issue of repair methodology, and Martin may talk about Kusile, where the repair methodology of one of the failings there had air pollution implications, and the steps that had to be taken to get that through became a little bit more complex than what it otherwise would have been. Technological advances. Okay, so and the one that's most spoken about here, I think, is the building information modeling. The construction industry in South Africa is traditionally a slow to take on new technological advances. This is mostly because of cost, limited knowledge, and the traditional resistance to change from tried and tested. There's quite a big regulatory regime, and the industry feels that they are compliant and they've worked themselves into a position of compliance, and to now start again, move away from the tried and tested is not always easy. Perhaps I should mention AI. There's a slow infiltration, it seems, from AI in relation to the construction industry, mostly at this stage in the management of processes. Of course, as with all AI, one has to have an understanding of this so-called hallucination, which is the ability of AI to create an aberration or a result which is completely wrong and completely inappropriate for what it's intended. And the result of that is you still need the necessary skill sets of people to oversee and monitor the results that are coming from the AI to ensure that we're not picking up any of these hallucinations, and to detect and to deal with them. Tariffs, our madman in America, one doesn't know where we're going to end up with the tariffs. Two effects from tariffs. One is it has an overall effect on the South African economy. And as I said at the beginning, because the construction industry is a fairly fixed percentage of our GDP, if the GDP drops, so does the overall amount of the construction industry's contribution. So one can only hope that there is some sense, although up until now, I mean, we've had, I think it's 9 weeks of unbelievable tariff wars going on. The other side of it, of course, is also that South Africa should be using tariffs quite clearly and concisely. And I gave you the example of ArcelorMittal, where there was no responsive action on the part of government, which resulted in the long steel business having to take a dive. Way forward. Is it all doom and gloom? I like to think not. My sense is, first of all, from a private perspective, on the private sector, we are a resilient bunch. That is one thing that us South Africans are. So I don't really have a concern there. My concern is more with the government, and in particular with the ability of the government to steer the economy in the right direction, number one, and number two, to also make good on its promises. I think if it can make good on its promises, and if it's able to deliver on what it is said is going to be the future of the construction industry, then we should be okay, and we should be on an upward trajectory. We just got to hope that our economy is able to sustain itself and to keep going in the right direction, particularly with, as I say, with the apparent mayhem that is reigning out there in the international economies, particularly in America. I think, yeah. So that's basically the background to what I wanted to give, and I'll perhaps hand over to you now, Shushi.
Thanks, Warren. Thank you for that. Just the one question on retention. With all these challenges, it's possible in the next few years that we could have an exodus of engineers leaving shores to other countries. Wouldn't that also become a problem for us as well?
Yeah, it
Or are you
is.
actually seeing it? Are you seeing it now that there are immigration?
No, I think we do see it, and I think what we see is the mature engineers, the what we call the greybeards, they were kind of put out to pasture to make place. Then what you had is you had the young up and coming engineers, and those young and upcoming engineers have the ability to move. They have mobility, so they're in demand. So instead of them coming to fill the gap, what's happening is you're having them looking elsewhere, particularly when South African prospects are not great. The result of that is you then have the newbies who are now having to shoulder all the responsibilities, and sometimes way beyond their capacity and way beyond their experience and way beyond what they should be expected to be doing. So it comes with risk. There is no doubt about it. There is certainly something to be said for having grey-bearded people, and I don't say that because I'm grey-bearded, but there is a value to having grey-bearded people around, just to be able to give you some sense of reality and just keep everything solidly on the ground. And I think it's a problem for us.
Perfect. Lisa.
Hi, Warren.
Thank you so much
for the. Sorry, I'm going to lost myself. Can you hear me?
Yes, I can hear you.
Cool. Thank you so much for that. My concern is more on the large construction companies exiting the South African market. I mean, what do you think that will do for the future of jobs, given that the construction industry does employ quite a number of professionals?
Yeah, look, my sense is that you may not see the big behemoths that we used to have. I think you will probably see a fragmented industry with much more players, but at a smaller scale. Of course, what that's going to do is that's going to require some sort of cooperation and involvement of more than one of them in some of the bigger projects, which has its project management challenges and the like. But I have less concern about the private sector than I have about the public sector, just because we are a nation of innovative, resilient people, and we're able to overcome. I mean, what we have overcome and what we will still overcome. I think we will probably surprise ourselves, but I'm confident that's going to happen. My concern is that the government does its part, and of course the economy, South African economy, is able to sustain itself.
Thank you.
Perfect. If there's no questions, we're going to move on to Martin. Martin, over to you.
Sushi? Yes, I'm here.
Yes.
I've been listening to Warren with absolute rapt and awe. So I'm just going to bring up the slides. Yeah, there we go. All right, can you see those?
I can see you, but I can't see the presentation list yet.
So we're just trying to find the presentation and bring it up.
Okay.
Can you see it now?
Yes.
Yeah.
Oh,
We're
thank
winning.
Oh, fantastic. Good morning. And I presume I'm no longer on the screen.
You honestly, I can see you and I can see the presentation.
Okay. Presentation is the important thing, I'm afraid.
Absolutely. Okay.
Okay, good morning to everyone. And Warren, thank you very, very much indeed. Excellent presentation. Thank you. Right, I'm just going to go through some new matters and some older matters that we've been involved with, and really addressing some of the concerns we have as far as what Warren just mentioned about the design problems we're facing at the moment, and also about the climate changes we're facing at the moment, and how it is affecting the claims. So the first one I'm going to bring up here is what they call the SKA, or the Square Kilometre Array. This is one of, to my mind, one of the most exciting projects we have going in the country at the moment. This is located in the Karoo, at a place called the Meerkat National Park. And what these are radio telescopes, which we are building as part of an exercise which is being financed by 14 countries, mainly in Europe. This is repeated, this array you see in front of you is repeated in Australia, and is controlled by a very large telescope in the UK called Jodrell Bank. So really what this is a radio telescope looking out into the cosmos, trying to do further investigations in not only into our own Milky Way, but out into the galaxies and out into the far reaches, and try to find out right back to the time of the Big Bang. So really it's very exciting if you're in that kind of field, and very exciting for this country, because the first 64 dishes that they put up on this site cost in the region of $3 billion. There are now 127 of these dishes in place and operating at the moment. And as I said, they're controlled from the UK. So these dishes rotate, and the dishes in Australia and the one in the UK, and all the information is fed into the UK, who then give the information out to their various holders, the other 14 countries. So just give you some idea of the size of these dishes. I'll go to the next one. You can give some idea of the size of the dish in comparison with the vehicle in front here. So they're very, very large dishes indeed, rotate, obviously controlled. And prior to this, there were 3 countries competed for this, going back to that, competed for this array. That was South America, Australia, and ourselves. In fact, we came out on top, but it was agreed that we would split it, or it was agreed by the countries who were financing. It will be split between ourselves and Australia. And that is, in fact, on construction at the moment. So the land has been given by the state, by the government, and it was originally, majority was farmland. I say farmland, it's really, as you see from, it's almost like a karoo, so it's really sheep. So those farms were taken over by the state, and these dishes are being erected on this at the moment. So involved on this is about 450 kilometers of road. You see some of those in front of you, and you see some of them there. And these roads are used really for servicing these dishes, and also used by the heavy vehicles and cranes in erecting these large dishes. So at the time of the event, which was a couple of weeks ago, the one reason they chose the Karoo is because you don't get much rain there. And of course, with the changes we're having with the environment and the change we're having with climate, we had severe storms up there, very, very severe storms. And what it's done is really taken away these roads. As I say, going back, of the 450 kilometers of road on the site, about half of those roads were existing roads from the farms, and the other half were erected as part of the project. Now, those roads have been absolutely devastated, as you see here. What you see in front of you is what you call a drift, a concrete drift, that allows you to drive through a small stream, and those have been completely destroyed. I'll go to the next one, and you see here, it's taken out The whole of the drains, the side drains have disappeared. Most of the gravel on the surface has been washed away. So really they've got to go back now, and we're in heavy discussions at the moment with the contractors and with the owners of this square kilometre array of what we're going to do with these roads now. So climate change is very, very, very much involved here. One of the reasons it was chosen because of the dryness, and now that kind of myth has disappeared, and we're not sure now. They're not sure how they're going to rebuild these roads and to what kind of standard are you going to build these roads. It'll increase the project cost considerably if you're going to put in what we call a normal road, which is a layered road with premix, or are we just going to go back and put in a standard gravel road, which you see in front of you here. So when we do a design, when the engineers do a design, we have what we call a 1 in, so you have a 1 in 20 or 1 in 30. So what that means is that you look at the statistics and the data for the last 30 years, and you say in the last 30 years, you experienced a flood of that proportion every 30 years. And if you're designing 1 in 50, the same thing. You look at the data for 50 years, and you say, all right, we'll design it for the worst case scenario within that 50 years. Of course, what we're getting now, we're getting a return every 2 or 3 years of a so-called 1 in 30 or 1 in 40 or 1 in 50. So, but that will only feed through into design over a couple of years, because you've got to, again, build up the data. So going forward, your designs will have to change to allow for the change in climate conditions, but they're not being changed at this stage. So we're still designing for a 1 in 30 or 1 in 40 design, but unfortunately we're getting those every couple of years, as you see here. So the engineers have got to really think again of how we're going to design even temporary roads or permanent roads, and what data do we now use. Do we say, in fact, we're getting a 1 in 30 every 3 years? Because that changed not only the design, but changing the way it's priced, changing the way it's specified. So it's a major concern, the climate changes, and I'll show you the next couple of slides on other projects where we're experiencing this problem. So going forward, you see on this one, this is what you call a drift, a concrete drift, totally undermined. The river hasn't in fact gone over it, it's gone under it. So what we've got to do with this drift here, we've got to break out all that concrete, take all that material away, and then redesign a drift. But again, what do we design now? Do we upgrade it and say, well, we'll design for 1 in 100 now? What do we design for? It's also a problem with insurers. So the insurers, they've insured, again back, they insured a gravel road here. They didn't insure for the ground around the gravel road, which is now being lost. So the insurers may well say, we'll pay you for the damage to the road. We'll pay for that. We're not paying you for put back that material which is being washed away, which was never part of the works. We have presented this to insurers. We're waiting for answers on that very question. So this is a very large cost implication to the client, because the client has to now go back and put back existing ground before the road itself can be reconstructed. So it has a very great knock-on effect, not only the cost of doing the job, but in fact the client itself, which we're having in this particular instant. Here you see the road has virtually disappeared. There is no road left. So here we've got to go back, got to re-establish that existing ground, and then rebuild the road from scratch. The road's gone. Here, we've got a little strip of gravel in the middle. The sides, what were side drains at the time, to carry normal water, those side drains have disappeared, and all the ground around those roads has also been washed away. So we've got to come back in. We've really got to rebuild the existing ground. And that was never the intention. And the insurers are going to say, well, we'll pay again for the damage to the road itself. We're not paying for putting back that virgin ground that was being lost. But again, we're waiting for that answer on that one. This is another drift. As you see, it's completely washed away. The whole thing had to be demolished and start from scratch to rebuild the road and rebuild the drift. Very bad here. This is, in fact, one of the worst areas here. The road is now sitting elevated above the existing ground. It's almost a point. Do you take the road away and drop it back now down to the new ground level? or you do build the ground level back up to that road. Again, there's a problem. If you rebuild the ground, it's, even though you compact it, it's compacted fill. So when you have another heavy storm, you'll go back to where you are here. It'll just wash it away again. So there's a lot of consideration here the engineers have to make of how to rebuild these roads. And there'll be a lot of discussion on this point. This is the bases for the telescopes or for the dishes. As you see, all these excavations have been flooded. The cables, which are highly sensitive cables, will all have to be checked out again once these excavations are emptied and cleaned out. The road here completely flooded. It's a very flat area, even though you can see a hill in the far. It's a very flat area. So when it floods, when it rains heavily, there's huge ponding that takes place on these roads. And there can be days or even weeks before the contractor can get back onto the site. Again, totally demolished road. You see here there was a river or a stream, not even a river, a stream went across here. It's actually taken the drift completely away and left this kind of donga right through where a road was at one stage. They've started the reconstruction work here, and here they're putting the ground back that's been washed away before they start rebuilding the road. So they're bringing material in from borrow pits, and they'll slowly rebuild that ground area, and then they'll start really reconstructing the road. What they've done here is they've taken the road itself away as well, and they're rebuilding the whole area again. So they're not going to try to build each side of the road. They've taken that road away, and they're going to just rebuild it from scratch and just drop the level of the road. Very bad dongas. You see, we're right down to the original kind of rock levels here. It really has caused a lot of damage. So there are climate denialists, but if you go to the Karoo and you see this kind of damage, then it's very hard to say we don't have a climate change. Here we've pumped out the base, and now we're going to have to check all those cables. Right. Next one I'm going to look at now is a design matter. This is a place called Shoshanguve Mall. This is a new mall going up in that area. In fact, it's a very large mall indeed. There is an existing mall, and this has been built right next door to the existing mall. And what these are conventional concrete columns, concrete slabs. And you see here, this is standard. Before you put the concrete slab down, you put plastic membrane down there to stop damp coming up to the floor, and then you cast your concrete. You see your columns, very conventional, and on the left side, you see the slabs going into place. So the slabs here, there's a beam there, that the bottom section is a beam. The one I'm concentrating on is the slab above. These are what they call post-tension slabs. You have two different types of slab. One is called a post-tension and one is called a pre-tension slab. So what happens with a post-tension slab, the mean post, is you cast the concrete first, and in the concrete you have tubes. And I don't know whether the next one, So inside the concrete you have tubes. And those tubes are cast at the same time as the concrete with the reinforcing. And once the concrete is set, you then have these cables through those sleeves or through those plastic tubes, and you put a jack on those. So I may go back a couple of times just to explain again. So that is really a profile of what the tubes look like. They are deformed slightly, so that when you pull those cables tight, you're tending to lift. That cable is trying to go straight, and you're tending to lift the slab, as you see there. As you pull it, the slab is lifted. And those are kind of jacks you put on the end of those cables to pull them tight. So what's been happening here is that when they pull those cables, as you see, there's some white marks on those cables. They measure very carefully as you pull those cables, as you stretch those cables. So you measure the extension on the cable, how much the cable is extended. And you work out, if you're putting 70 tons, for instance, on that cable, you work out how long the cable will be stressed or pulled. So you use that correlation between how much the cable is pulled and how much the load is on the jack. And if those two tie up, then you've really satisfied that you've achieved the required stress on those cables. What was happening here is they were getting the full load, the 70 tons, but they weren't getting what you call the extension on the cables. So they went back and forth. They sent the cables to the local university for checking. They then sent them to Germany to check. The cables seemed absolutely fine. There was nothing wrong with the cables, but they couldn't get over this problem. They did a few slabs, going back to those slabs. They did a couple of those slabs. They pulled them, but they couldn't take the props away because they were not achieving the extension on the cables. So eventually, after we did a lot of investigation, it was found that the calculations were incorrect. And in fact, these calculations have been used for a long time on other projects, and they were wrong. So the design of the original extension on the cable was wrong. So in the meantime, they put more cables in to overcome the problem. What they thought was a problem, there was never a problem. It was just that the extension given, the figure given, was wrong. So they put a lot more cables. It's done like 3 million rands more cable. No need to have done that. And then the design was revised, and everything was hunky-dory, and they went ahead with the remainder of this Soshanguve Mall. But what we then had to do was look at the other projects they'd done prior to this, where the same calculations had been used to ensure that there were no other problems on the other malls and the other buildings, and they're all checked out, thank goodness. But here was a typical example that someone had made a mistake in a calculation some years back, and it had been accepted, and no one went back and said, we need to check this now and again. No one checked that design, and this was the first really failure they had that allowed them or forced them to go back and look at that original design calculations. So it's a problem the engineers have got to keep up with, that you really must double check your design, and I'll get that on another couple of other failures we've had on the next couple of slides. That's a typical hydraulic jack. So you put the hydraulic jack on the cable and you pull the cable. The tubes you see are hydraulic oil, and that slowly pulls the cable. The other end of the cable is anchored, it's tight. You just pull one end, and then once it's pulled and it's tight, you then epoxy it. There's another jack. That jack is partially extended, as you see. So it's pulled one. There's 3 more cables to pull. Once you pulled it out, it's locked. It's locked in position. Once all 4 cables are pulled, you then grout it up. This is a very large jack on a beam for a bridge. You see the other cables next door to it. Some have been pulled. The one immediately above has been pulled. There's a lock-off plate you see has been in position. What will happen now, they'll come back. They'll cut those extensions, those cables sticking out will be cut off. The cables then will be grouted up, and that whole of that beam will then be lifted in position onto the bridge. So that's a typical post-tension system. A pre-tension system is when you go out and buy let's say a lintel for your house over a doorway. That lintel is pre-stressed. So they pull the cable and they then cast concrete around the cable. Once the concrete is set, hardened, they then can release and cut the cable, and that stress then goes into the concrete. So that is pre-stressed. This is post-tensioned. So most of the large projects on site like this are post-tensioned. The little lintels, etc., are pre-stressed. One of my pet problems at the moment, which is tailings dams. And this is I've just shown this picture as a typical example of a tailings dam. And if you've been in other discussions or been in other seminars, I go through quite extensive discussion on the failures of these dams. But this is typically what a dam would look like. It is tailings material. That's material that comes from a mine. The material has been crushed. It's normally crushed rock. It is mixed with water, and then that is then treated to remove whatever you want, whether you want gold, whatever you're looking after that material, you extract that from that material. The waste material is then discharged onto a tailings dam or waste dam like this. And this material will last for many thousands of years in this position. The problem comes, I'm not going to it long now because we're not talking about tailings collapses, but this is flat topped or slightly dished. And what happens here is the water is retained on top of that dam and then slowly discharged into a holding dam, and that water is then taken back into the mine for reuse. But the problem arises is when this dam is left and the mine is closed and no one is supervising that dam. What often happens is the dam fills up with water and it breaches the top of that dam and you have a dam failure. And at the moment we're getting about 2 of these failures a year around the world. We just had one recently in Zambia. We had one a couple of years ago in South Africa. Many cases it kills a lot of people. Unfortunately, the latest one in South Africa didn't kill anyone. And I don't know the one in Zambia. I don't think it's killed anyone. But that's fortunate. But in many cases, not only causes death, but it causes a huge amount of pollution. But that's a tailings dam. Now, what we're doing here now. Now I'm frozen. Why am I frozen? Yeah. This is Harmony. This is down in the Free State. This is an aerial shot. So the existing tailings dam, now going back to what I showed you just now, there's the tailings dam. So in the middle of that tailings dam is a pond of water. So here on the right-hand side is the tailings dam, the existing tailings dam, and there's the pond of water. That green water is sitting in the middle of the tailings dam. That is typical how a tailings dam looks during the life of the mine. On the right side there is they're extending the tailings dam. So this is a new section of the tailings dam being built by a contractor at the moment. So to build a new tailings dam, you've got to clear the area. You've got to flatten the area like they have done there on the left-hand side. And then you've got to put down a plastic liner. You've got to put this liner down to stop any of the material from the tailings, which is highly acidic, very unpleasant material, leaching into the groundwater. So you line that new tailings dam, which you see there on top, on the left-hand side. You line it with plastic, you seal that plastic. Under the plastic, you put clay, again, as a protection to stop water getting into the ground. Under the clay, you put drains, and that drains then any water that gets through either the plastic or the clay is then led away. So you're trying to maintain your existing groundwater, the cleanliness of your groundwater. And try to give us some idea of the size of this. If you look right down the very, very bottom, there's like a large white square, and in that square is a little black square, and that little black square is about 10,000 square meters. So it's very hard to give you the kind of size of it because you can't even see a truck. But these are very, very large structures, these tailings dams. And the new tailings dam there is going to be about a third, not even maybe a half of the size of that existing one. So that's what they do with tailings dam. They keep adding on to it. So maybe in 10 or 15 years time, they'll again add on to this existing tailings dam. The problem with this plastic on the top left-hand side is the plastic is very susceptible to wind damage. So what we often get, this is a typical inside a tailings dam where the plastic itself has been ripped off the surface, has been curled up, and has been destroyed. That plastic can't be reused. It's bent, it's crinkled, it can't be put back. So that's actually got to be thrown away. Excuse me. There's a typical example. That ground you see underneath is a clay layer, again, as I explained, to stop penetration of water into the groundwater. Again, that surface now had to be cleaned off, had to be checked before the new plastic line is put into place. Okay. This is now Insakaba. This is Insakaba Bridge. This is down near Lusikisiki in the dear old Transkei area. And this is a new bridge for the extension to the N2 going between Durban and Cape Town. We had previous claims on this with the concrete, which were PI claims. When they were pouring the big concrete bases for these two pylons, in fact, the one on the left there, the concrete came out. You see, this is one of the pylons here. I was down there about 3 weeks ago. That pylon now is almost complete, ready to start putting the cables through. When they were pouring in large base under this pylon, the concrete came out with holes in it. It came out very badly honeycombed, and the concrete had to be removed. What the problem now, here's the concrete you see here. I know if you're not a concrete fundi, it may not make much sense, but that concrete is highly honeycombed, and in fact has been rejected. So what we had to do was to break that concrete out. We had to bring about 450 cubic meters of concrete. It cost about 20 odd million to break that concrete out. But we had to break it out without causing any damage to the existing reinforcing steel, which you see in front of you there. So we removed that concrete using a high pressure water, so the steel itself was not affected.
Sorry, Martin, just in the interest of time, and this particular project is what the engineer did wrong.
Sorry, how long have I got?
We've gone beyond time.
I'll be on time. Oh my goodness. Oh my goodness, I've only started. Okay. Sorry guys, I'll show you one more shot. Sorry, just going down. We were down there 2 weeks ago, and as you see, the site itself, they're building the road. The road has been flooded, and what is happening, a lot of the sides of the excavations are collapsing, which you see on the right-hand side there. And it's a problem. Transkei is obviously subject to a lot of water. That area is causing real havoc with the roadworks down there. Okay, Shushi, I'll stop.
Thank you for that. From what I can see, that we don't have to worry only about external challenges, but also internal challenges. For example, not checking a design for many years. And I would think that you have to, because parameters change, climate changes, scope changes, etc.
Absolutely.
So very, very insightful. Guys, if there's no questions for Warren and Martin, we are going to wrap up. Anything from your side, Fiso, Nadia? Anybody?
I think we should have another session with Warren and Martin to take us through more examples, and Martin can share some more of his war stories.
Yes.
Thank you.
Absolutely happy with that.
Thank you. Thank you, guys.
Everybody.
Thank you, everybody.
Thanks, guys. Thank you, Warren. Thanks, guys.
Thank
Shushi.
Thank you.
Thank you. Bye, everybody.
Bye-bye.